Hello everyone and welcome to PC Retro Tech. In this week's video I want to revisit the topic of 3D games that run on the IBM PC and the XT. Now I've had a look at this on the channel before. In fact, I even wrote some code myself for rotating 3D objects really fast on the screen on an IBM PC. And if you want to see that video, there's a link above. Then I went on to have a look at what the 3D games and demos of the era were doing, but it turns out I overlooked the most impressive examples of that. So I want to share with you today what I've learned since then. And I also want to revisit one of the demos that I showed on the channel, because it turns out I was filming that very late at night, and as a result I overlooked one of the most impressive things I've seen in a demo to date. So I want to share that with you at the end of the video, so stick around for that. Now the first 3D game that I want to show you is Elite, and it was a real facepalm moment for me when I remembered this game that I hadn't put in the video. And that's because, not that I played it before in the past, but because there was a source code release recently for the BBC version. And people have gone through and commented that source code, and there's been deep dive articles on how it works. And it's really impressive stuff. I've read through those articles. So basically everything revolves around drawing straight lines, at least in the original wireframe version. And they use a very fast line drawing algorithm for this, of course. I think they're using DDA, but the deep dive said Bresnaham. So DDA is where you take an approximation to the slope of the line. It's usually a fraction that approximates the slope. And you make the denominator of that fraction a power of 2. And so the numerator is the only thing you ever need to write down, because the denominator just remains the same all the time. And you just take that number, that slope approximation, you just add it to itself over and over again. And whenever it overflows the register that you're storing that value in, you move by 1 pixel. And so that's all there is to it. It's an incredibly simple algorithm for drawing straight lines. Especially if you're wanting to, pre-compute that slope, you can get extremely fast line drawing. So I don't know what they're doing here, of course, because this is filled polygons, but I do know in the original they even have face culling. So this is where if you have a wireframe object, you don't want to be able to see through the object. You only want to see the faces that are pointing towards you. And so you have to remove the faces that are facing away from you. And this is really quite some work to code up. So it's very, very impressive what they've done here. There's other innovations in this game. They have this little oval thing here. And this is basically for keeping track of the objects that are coming towards you. For example, enemies and so on. Now, I don't know whether we're going to see one of those quickly. In fact, here is one now coming in. And you can see that these are spacecraft, and they're rendered in 3D. And you can see just how smooth that is. It's so fast I can't actually keep track of this thing easily. But look how quickly this is rotating and moving. And not only is it rotating in 3D about its own axis, but you're also adjusting the orientation of your ship, and moreover, you can move around in space in 3 dimensions. So this is quite hard to do, and this is another effect, the exploding things. I ran into something, so of course I've died now, but that shows just how sophisticated this game was. Really, for 1987, it's a marvel, and very, very famous because of the extreme levels of optimization that they went to in order to make this work. There's a lot of effort went into storing the structures that store the data really efficiently. They don't waste any bits. And bear in mind, on the BBC, it was of course 8-bit machine that it was running on. So very impressive for the day. One of my favourites for sure. The next game I want to look at is called Arctic Fox, and this was recommended by one of our viewers, so thanks very much for the suggestion here. It was available on Commodore 64, Amiga, Amstrad CPC, Atari ST, Apple II, and now this version on the PC in CGA, of course. I'm just going through the preview mode here because it's the easiest way to see the 3D rotation. It looks like some version of wireframe, but it is using face culling, so you only see the lines on the faces that are facing you. And I guess they're getting anywhere up to about 8 frames a second in these objects. This is the best way to see it because that's all that's happening here, they're just rotating the objects. So if you go into the game itself, you'll see that there do look like some shaded polygons, but I think this is really just trickery to make it look that way. So let's do that now. Let's go into the actual game itself. I'll just go into the beginner mode and you can see how it plays. You can see that they're using the standard trick of blocky projectiles and also a small viewport in the middle of the screen, which is saving time when rendering stuff. So you can see there's a couple of pyramids in the background there, and you can see what I mean by it seems to be shaded polygons. But I think that there's probably some trickery going on there. It's probably not quite as complicated as that. But I think for 1987 this is particularly impressive. That there's maybe only 3, 4, 5 frames a second here, but given the detail of the scene that's being rendered and just knowing the amount of mathematics that's involved to do this, it's an impressive example, especially compared to some of the other ones I showed. Now, one of the tricks that was used in games like this was to adjust the level of detail depending on how far away things were. So the far away objects, they're only drawing a few of the lines that are required rather than all of them, and that saves a lot of computation time. So there were many tricks that were used. You can see, of course, they're using just very, very basic line outlines for things as well. There's not a lot of, there's no textures or shading or anything like this, as you'd expect for games of this era. So it is a particularly impressive example, and yeah, definitely belongs on the list of great 3D games of the era. Now, the next game I wanted to show you is called Alpha Waves, and there's a little bit of an interesting story here. I tried to show this game in the previous video, and of course this screen comes up and you select CGA, which is what I have here, and press F1 and nothing happened, it just hung. But this version does work. So the difference is that this is the American version of the game, which was actually called Continuum rather than Alpha Waves. Alpha Waves was the European version. Now, I've examined the files of lots of different copies of the European version, and they're all the same. And it really does not run on this XT, but the American version, which has different file sizes even, really does run on it. So you can see here that you have really quite fast 3D rotation. It's really impressive for a 1990 game anyway. Now, this is the copy protection screen, and I'm not going to be able to get past this because I don't have the manual, and I don't have a cracked version of the American version of the game, which is the one that runs on original hardware here. So what happens a lot of the time is people crack the games and then they rewrite them so that they'll run on DOSBox, and then they don't run on the original hardware anymore. I've seen this, for example, with Bruce Lee, which doesn't run in colour or in full colour on original hardware. If you use the DOSBox version, it runs at like 10 times the speed that it should. So it's just totally unplayable. So this is a little bit of a shame that this happens. But there's some things to point out here in this copy protection screen. This is obviously shaded polygons, and you can see that there are basically 8 different objects here rotating around the screen in various ways. And moreover, some of these objects are not even convex. It's possible for some of the faces to occlude other faces, and they're even having these objects intersect one another. So, for example, the star sits in front of the pyramid and blocks part of the view to the pyramid. So this is basically the hardest possible thing you can do, other than have sort of semi-transparent sides on the objects, the so-called lens effect. And it's really impressive that they've got 8 of these at a fairly good size, on the screen at the same time, all rotating. So this is very, very highly optimized, I'm quite sure, and definitely belongs on the list of games that are the most impressive 3D ones. Now, I really want to show you this game, so what I'm going to do now is switch to a DOSBox version online, which is much faster because it's not running on original hardware, but you'll be able to see the game itself in operation. I want to show you because it's just so unique. Now, I'm just running the Alpha Waves demo, which is one of the options in the main menu, and you can see that this is a really unique game. Basically, you're bouncing around on these pads, and then you can move forwards, and the object is to find an exit and move on to the next level. So this is actually just the help screen to show you how to move about and how to rotate your craft and so on. And in a moment it will move on to a full screen demo, and you'll be able to see what the game runs like. Now, bear in mind, this is not original hardware. This is running online in an emulator, and it's running at much higher speed than my XT will run. But even still, it's extremely impressive that a game like this exists and was playable on an XT. I don't know why the European version doesn't work, and that just may be down to the fact that when they cracked it, they broke it, which is really a shame. I think there's a lot to be said for correctly archiving stuff. Some people want games to be archived in this manner because they will get more playtime, because it's easier for people to access the games. Other people really want the original games to be archived along with the manuals and along with everything that came with the game originally. You can see here that you have some wireframe graphics in addition to the other stuff that's moving about here. So really, really impressive for the day. So 1990, it's a little bit later than the other ones we've looked at, but definitely belongs on the list of the top 3D games of the era. The final game that I want to show you is Flight Simulator 3, the Microsoft Flight Simulator. This is a viewer's suggestion, and it wouldn't have occurred to me to try this on an XT, but it works just fine. It's a little slow, as you can see, but it's definitely, it's more or less playable. Now, flight simulators turn out to be very hard, even for very modern computers with advanced graphics cards. They have, very, very realistic looking ones these days, almost photorealistic, but they tend to jerk a lot when you go into new scenery, perhaps because they're doing a lot of loading from disk or something like that. I'm not actually sure of the reason, but people who play first-person shooters, which are dead smooth and are even played in competition, often express surprise when they see just how jerky flight simulators are on modern hardware. And I guess that one of the reasons may be because modern flight simulators don't just simulate scenery that you're flying over, but also simulate the aircraft. And it's much more of a fluid simulation than you would imagine. So that's one of the reasons that I think modern flight simulators are so slow. But this is pretty impressive, actually. If you look at the amount of polygons that would be required, if that's how you were doing this, I'm pretty sure it's not. But if this was just done with polygons, then there would be an enormous amount of computation, really too much for the CPU in this machine. So it's clear that the people who wrote this had a lot of tricks up their sleeve to make this fast. I remember when I was younger looking at this and thinking, wow, this is so slow. Why did anyone ever write a game this slow? Why can't they make it faster? And I didn't appreciate at the time just how hard that would be and how much they'd already pushed the limits to get it to run like this. It is truly impressive, and if you just imagine the scale of a game like this, the other really impressive thing about this is it fits on a couple of disks. It's compressed, I think it's 320 kilobytes, which is absolutely stupendous given the number of different cities you can go to and the effects and so on that are all crammed into the disk. Anyway, I'm not going to show any more of this because we've actually done quite a bit of Microsoft Flight Sim 3 on the channel recently, but I just wanted to show this running on an XT as another example of a pretty early game that was quite impressive. This is 1988. There was a Microsoft Flight Sim 1 and 2, which I'd love to be able to show you, but unfortunately the versions that I can find online, well, version 1 is corrupted, and version 2 I can't find the utility that they use to create the disk image, and WinImage, for example, just doesn't read it. It just shows a 4 kilobyte file. So again, a lot of these things are set up so that they can be used with DOSBox rather than on original hardware, which makes it a little bit more tricky. This one, at least, was archived as both an original disk image and a DOSBox image, so I was able to get this one to run. Now, the final thing that I want to show today is, again, this demo called Vectra by the Physical Crew, some members of which later went on to become the demo scene group Triton, which is really quite a famous early PC demo group. And I showed this demo in the previous video because I wanted to show early examples of 3D rotating objects, and I was particularly impressed by this one, especially later in the demo when they have a lens effect, which is where you have semi-transparent sides on the objects. And it's impressive enough. It is running here on a 386. In the previous video I had it running on a 286 because I wanted to do a comparison with something as close as possible to my XT. And of course this is VGA and not CGA. But it's still an example of early 3D rotation. But I think the story I'm going to tell is probably going to make a few people chuckle, especially members of the demo scene community who already knew all of this stuff. But for me it was totally a revelation when I discovered this since making that video. So because I was recording the video late at night and I didn't want to wake up my neighbours, I actually selected, without even thinking, the no sound option on this demo. And what I didn't realise is that this demo has a soundtrack, but it doesn't require a sound card. So the entire soundtrack is played through the PC speaker. And now, of course, I knew that you could do very sophisticated sounds through the PC speaker because there are some early games that did this. But if you told me that you could do an effect like this lens effect, which is really hard to do, at the same time as really CPU intensive, sound that sounds like it's a recording rather than just, a square wave beeper, which is after all what the PC speaker is, I would have told you to go away, that you're wasting my time. But this demo actually achieves that. Moreover, I've discovered that a lot of these early demos actually did that. They had music systems which were, sophisticated enough that they actually offered an option of running on the PC speaker and then would give you, fairly reasonable fidelity sound at the same time as the actual demo. And I have no idea how this is possible. I really haven't got the foggiest clue how this is done. So this totally blew me away when I saw it for the first time. It's just not something that you get, when you watch some video of one of these demos on YouTube. So what I'm going to do now is hold the camera right up next to the PC. There will be some jerking as I move the camera around, but I want you to hear the sound up close because unfortunately it's very, very quiet and isn't easy to hear. So let me just disconnect the camera here and I'll hold it right up to the side of the box. Sorry it's not very interesting to look at, but the sound is what we're after here. So you can see that this is really a soundtrack playing through the PC speaker at the same time as, doing complex 3D objects on the screen. So anyway, I guess that just shows how ignorant I am of the early PC scene. Really impressed by this demo, and I think it fully deserves a place in history. Anyway, that's all I have time for this week. There'll be another video coming soon on some repairs that I did. Look out for that. Don't forget to like and subscribe, and we'll see you in a later video. Bye.